All right, picture this. That mysterious electricity bill lands in your mailbox every month. It's full of numbers that can feel like, I don't know, a foreign language. Watt hours, kilowatt hours. Honestly, I used to just sort of sigh and pay it, thinking it was some kind of like cosmic tax. Have you ever felt that way? Like you're just paying for magic you don't quite understand. Well, our mission today in this deep dive is to pull back the curtain on that magic. We're going to demystify the concept of electric energy, the very thing that, drives your home and calculates those charges, and hopefully reveal how truly understanding it can empower you to make smarter choices, maybe even save you some money along the way. We're really breaking it down so that even if you're completely new to these concepts, you'll walk away feeling completely informed and in control.
Absolutely. And the material we're drawing on today is designed specifically for that it's really accessible, aimed at beginners. So if you've ever felt a bit overwhelmed by terms like watts or amps, don't worry. Our goal is for you to leave this deep dive with a clear, practical understanding that feels genuinely useful, not just theory.
Okay, fantastic. Let's unpack this then. If you've been with us before, you might remember us talking about electric power, which we defined as the size of work being done, like instantaneous strength. But today we're diving into electric energy, which is subtly but, well, significantly different. It's about the amount of work done over a period of time. So if I'm getting this right, it's not just how much power something needs, but for how long it uses it. Is that the key?
Precisely. That how long is the crucial piece. And there's a really good analogy for this. Imagine you're out running for exercise.
Okay.
The instantaneous strength you're putting into each stride might be the same. You're equally strong in that moment. But the total amount of exercise you get is vastly different if you run for just 1 second versus running for an entire hour.
Makes sense.
The longer you run, the more total exercise you accumulate. And this is exactly how it works with electricity. A 200-watt fan operating for just 1 second uses very little total energy compared to that same 200-watt fan operating for a full hour. Electric energy is the concept that captures this crucial difference over time.
Okay, so let's nail down the unit then. While watts, W, typically use seconds as their base time unit for just power, electric energy shifts to using hours for measuring the amount of work. Is that right?
That's it.
And that's why we get watt hours, or WH. It's simply power multiplied by time. So the formula is basically electric energy, power, X time. Simple enough.
Exactly. And to make that really concrete, think about that 200-watt fan again. If you use it for 1 hour, it consumes 200 watt-hours of electric energy. Simple. 200 watts times 1 hour. Use it for 2 hours? Well, then it consumes 400 watt-hours. That's 200 watts multiplied by 2 hours. This simple calculation is really the key to understanding your consumption at home.
Now, a quick question just popped into my head, though. If it's watt-hours, why do I always see kilowatt-hours or kilowatt-a on my electricity bill? Is that just a bigger version?
That's a great question. And yeah, you've basically got, it's simply a larger unit. Think of it like grams and kilograms or meters and kilometers. A kilowatt hour is just 1,000 watt-hours. Kilo means 1,000.
Oh, okay.
We use it because homes consume so much energy over a whole month.
Yeah.
If we use just watt-hours, the numbers on your bill would be enormous, maybe millions.
Right, that would be confusing.
Yeah, kilowatt-hours just make the numbers much more manageable to read and understand. It's purely for convenience.
Okay, that makes sense. And here's where it gets really interesting, I think, because this whole concept of electric energy directly connects to the most practical application for you listening. Your electricity bill. Electric energy, measured in kilowatt hours, is the very basis for how those charges are calculated each month. It's not abstract anymore.
Exactly. And the device that actually measures all of this is the watt-hour meter, sometimes called an energy meter. You'll find one of these on pretty much every home, every building, everywhere that uses electricity from the grid. It measures the total amount of incoming electricity. And while you might still see some older mechanical types around.
Was it the spinning disc?
Yeah, those.
Yeah.
But electronic meters are much more common now. They do the same job, just digitally.
I always found those old mechanical ones kind of fascinating. The principle seems so simple. Like, the electricity flowing in creates a magnetic field, right? And that makes the little metal disc inside spin.
That's exactly right. It's called an inductive watt-hour meter.
And the more electricity you're using at any given moment, the faster that disc spins. It's like a little speedometer for your home's energy use.
It is a very direct visual indicator.
Yeah.
And that spinning disc, through a set of gears, turns the number dials on the display.
Ah, the little number wheels.
Precisely. So those numbers just keep counting up. To figure out how much electricity you use in a month, the utility company simply reads the meter. They subtract last month's reading from this month's reading, and voila. That difference is your total electric energy consumption for the period, usually in kilowatt hours.
It's actually quite straightforward when you break it down like that. No magic, just mechanics or electronics counting usage. So, okay, what does this all mean for you, the listener? Now that we understand electric energy and the meter tracking it, how can we actually start saving money? Because, let's be honest, that's the real payoff for understanding this stuff, right? Lowering that bill.
Absolutely. And the key insight from the material we looked at is this. Yes, turning off unused lights is good. It's a positive habit. We all know that one. But the most effective approach for significant savings is actually to reduce the usage time of electronic appliances that have relatively high power consumption.
Okay, so it's about identifying the big energy hogs, not just the little things.
Exactly. It's about focusing your effort where it counts the most. It's not just about switching everything off, but knowing what uses the most power.
That makes so much sense. And our sources actually pointed out some specific examples of these high power items. Things like,
Yeah, things like your rice cooker, washing machine, definitely the air conditioner, and even the vacuum cleaner.
right, those can really draw a lot of power when they're running. I've always been kind of obsessive about turning off lights, walking out of a room. But you're telling me my rice cooker just sitting there on warm could actually be a bigger energy drain than leaving a light on? That's
Yeah.
genuinely surprising.
It really can be, depending on the light, of course. But let's take that electric rice cooker example. Even when it's just in its insulation mode, that keep warm setting, it consumes roughly 100 watts.
Wow, 100 watts just keeping rice warm.
Yep. Now, compare that. It's double the power of a typical standing fan running normally, which might be around 50 watts.
Okay.
And here's another way to think about it. 100 watts is equivalent to continuously keeping 4 25-watt fluorescent lights on all the time.
4 lights, just for the keep warm function.
That's the kind of continuous draw I can have. Imagine leaving 4 lights on 24/7 in your kitchen. You probably wouldn't do that, right?
Definitely not. Okay, that really drives home the practical advice then. Cooking, maybe, just the amount of rice you need so you don't have to keep it warm for hours.
Mm-hmm.
Or just actively avoiding using that insulation function for long periods. That could be significantly more effective for saving electricity than, say, worrying about unplugging my phone charger the second it's done.
It very likely could be, yes. It's about being strategic with those high-consumption appliances. It comes down to developing what the source material called wise living habits. This knowledge isn't just about understanding the physics or the numbers. It's about consciously considering your energy consumption in your daily life, being an informed consumer.
So let's just quickly recap our deep dive then. Electric energy isn't just about power, the instantaneous size of work. It's the amount of power you use over a specific time, watts versus watt hours.
Mm-hmm.
It's accurately tracked by those meters on our homes, usually calculating in kilowatt hours, to determine our electricity bill.
Right. The meter reading is key.
And crucially, understanding which appliances have the highest power consumption, the energy hogs, allows us to make some pretty significant savings through smart usage habits, like, cutting down the time we use those specific devices.
Exactly. This knowledge really isn't just theoretical stuff. It's a practical tool. It empowers your daily life, helps you make more informed decisions, and ultimately helps you manage your resources and your money more effectively.
Absolutely. So as you go about your day now, knowing that seemingly small habits with specific high-power appliances can actually have such a large impact. Maybe think about this. What other hidden energy uses might be lurking in your daily routine, things you haven't considered yet? And how might this deeper understanding of electric energy shape even more of your everyday choices going forward? Something to mull over until our next deep dive.